Okay, and so here we're going to, there's one section in Chapter 1 and a couple sections in Chapter 2 dealing with categorical data. And we're going to talk about summarizing categorical data and displaying categorical data, okay? Okay, and so categorical data tells us what type or what kind, okay? And so you could imagine, we have some kind of data table. So imagine a data table, and maybe we looked at I don't know, cars in a parking lot, okay? So we gathered data on vehicles in a parking lot. And there's all sorts of information we could gather. We could gather a bunch, and so let's say one of these columns is the make, another will be the model, and then, I don't know, number of doors. Perhaps we can get the year. I don't know, okay? And so we're just going to look at one of these columns. Let's say we look at the column of the make, okay? So this make is categorical. And so let's say, we have a Ford, and then a Honda, and maybe a BMW, okay? And so we can, and let's say we had a total of 100 vehicles in the, or maybe just 20 vehicles, okay? So 20 vehicles total. Okay, we can create a summary. Summary table, and this summary table will be called a frequency table because it will show the frequency of some of these things. So if we're going to summarize the make, all right, maybe we have Ford and Chevrolet, Honda, Toyota, maybe BMW, okay? And then so let's say 2 vehicles are made by Ford, 3 by Chevrolet, 5 by Honda, 3 by Toyota, okay? 2 by BMW, and then I don't know, what other brands might we see? I guess we can have, well, we'll just do other, okay? We'll say everything that only had one vehicle, and then maybe we have a total of 5, okay? So other brands, okay? And so this is a frequency table, because we have basically some of the brands and then the frequency at which they appeared, okay? And then we can have another column here called the relative frequency. Okay, and the way relative frequency goes is we just divide the frequency by the total number of vehicles. So I'm pretty sure these add up to 20, okay? So we have a total of 20 vehicles, okay? So what percentage of the total vehicles are Fords? That would be 10%, right? So we would do 2 divided by 20 is equal to 0.1, okay? For Chevrolet, we have 3 divided by 20, 15%, okay? With Honda, that would be 25, Toyota would be 15, BMW 10, and then the other vehicles, all of the other brands combined, 25%, okay? And so that would be a relative frequency table. Is this all right? Okay. We could further split this up, and maybe we'll take the same data here, okay? Or I'll just take this part, and we can create something called a two-way table, okay? So so perhaps we have another column, not just so we have make, model, and then we'll call this body or type. And so maybe you know, it's a sedan or sedan, a coupe, and et cetera, et cetera, et cetera, okay? And so what we can do is we can look at 2 categorical variables and create what we call a two-way table. Okay, so we'll have 2 categorical variables. And so that will be make and type, and we're going to create a two-way table, okay? So our table will have, on one side we'll have make, and we'll have the same ones, Ford, Chevrolet, Honda, Toyota, BMW, and then kind of the other category, all right? And I guess I'll draw horizontal lines here, and then as far as the type of vehicles go, we can have a sedan, and I'm just making stuff up. We have coupe, we'll say truck, SUV, we'll say SUV or van. Okay, we'll combine those two together. Okay. All right, and then so Ford, maybe we had 1 sedan and 1 truck, for the total is 2, okay? And then maybe both Chevrolet vehicle, we'll say two trucks and 1 sedan for a total of 3. We'll say maybe all, we'll say 3 sedans and 2 SUVs for a total of 5. And so this is a two-way table, and maybe we have 2, or I don't know, 1, 1, and 1, and as for the others, I don't know, I'm just making stuff up here. Okay, and so as far as sedans go, we have 1, 2, 3, 4, 5, 6, 7, 8 sedans, 3 coupes, 5 trucks, and 4 SUVs and vans, okay, for a total of 20 vehicles. So this is called a two-way table. Is that okay? Does that make sense? And then so we can say, you know, of the, we can have a few questions. Of the vehicles, how many, we can say what percentage of vehicles were sedans? And you would say 8 divided by 20, 40%, right? Okay, and then we could say what percentage of Honda vehicles, Hondas were sedans. And you would say the fraction there would be 3 out of 5, or 60% of the Hondas we observed were sedans. Okay? And this is just something like that. And obviously, the two-way table doesn't have to be so big. It could be as small as 2 by 2. It could be like left-handed versus right-handed, male or female, or something like that. Okay, it could be smaller. It could be expanded out. Okay, and so that's a two-way table. We can display our categorical data using bar charts. Okay, so let's see. Okay, so here we have this frequency table. We can turn it into a bar chart. Okay. And with a bar chart, on one axis we will have a number line displaying the frequency. Okay, and so this will start off at 1, 2, 3, 4, 5. Okay, and then over here we will put the categorical variable. So here would be the make of the vehicle, and we have Ford, Chevrolet, Honda, and so Ford, we have 2 vehicles. So I would draw a bar that goes up to 2. With Chevrolet, I have 3. So I draw a bar that goes up to 3. And with Honda, we saw 5 of them. Okay, and then Toyota, there were 3 of them. And then BMW, there were 2. And then with the other vehicles, there were also 5. Okay, so we have that. This is called a bar chart, and it's for categorical data. Okay. Now, the arrangement of these bars are arbitrary. The arrangement of bars don't matter, okay? It's arbitrary. So, if we wanted to, I could put them, I could put them in order from kind of the greatest to least, and I would have something that looks like this. Okay, and this would be other, Honda, Toyota, Chevy, Ford, and BMW. Okay? And again, I still need 1, 2, 3, 4, 5. Okay? Both of these would be equally valid. Okay? the bars should be the same size. And one thing to note, just stylistically, we generally put small little spaces between the bars, okay? So we often leave small gaps between the bars. Okay. And so this is what we have for the way to display categorical data. Okay. Okay. There is a question of variation. Okay. And so variation exists throughout statistics. Okay. And so the idea, so for categorical data, okay, and we'll talk about variation for numeric data next week, but for categorical data, okay, variation is the idea of, are things quite different from one another, or are they quite similar to each other, okay? Are things in our data quite different from each other? Or are they quite similar to each other, okay? You know, at least with respect to the variable that we're talking about. Okay, so let's say we have a categorical variable, okay? So let's say we have the variable age, okay? But we're going to be recording age as a categorical variable. So we will have, so normally when you ask someone, what is your age? They will often reply with a number, okay? And so we often think of age as a numeric variable. But age could be categorical, okay? So in a legal context, it doesn't matter if you were 20 years old when you commit a crime or 60 years old when you commit a crime. You will be tried as an adult. It does matter, though, if you're 20 versus if you're 14, okay? If you're 14, you'll generally be tried as a minor, okay? Unless the prosecution is really has it out for you, okay? And so we can use age as a categorical variable, and we can say minor, and this would be basically ages 0 through 17, and then maybe we'll have adults, and then but we'll also have seniors, okay? So this will be 18 through, I guess, 64, and then we'll have 65 plus. Okay, so we'll have 3 categories for, we will turn age into a thing where we have 3 categories. Okay, and so we will have, imagine 2 groups of people, and so we'll have minor, adult, and senior, okay? so maybe, you know, with a number line here, I don't know, got some kind of frequency count. All right, or if, you know, if we wanted to make a frequency table, so I'll just have a minor, adult, senior, so this will be age and frequency. Okay, so we'll say 15, 3, and 1. Okay, so this is one group. And then in the other group, we'll have minor, adult, and senior. Okay, and then so we'll have age here, and we'll have minor, adult, senior. And as far as frequency goes, we'll say 6, 7, and 6. Okay. All right, and so my question to you here is, we'll call this group 1 and group 2. Which group has more variation with respect to age? What do you guys think? Does okay, so those of you who think group 1 has more variation with respect to age. Okay, and those of you who think group 2 has more variation with respect to age. Okay, and the answer is group 2 definitely has more variation with respect to age. Okay, so why is that? Okay, well, just you know, close your eyes and imagine yourself in group 1 and imagine yourself in group 2. Okay, if you're looking around the room with group 1, what do you see? You see just a bunch of kids running around, right? Okay, if you picture yourself in group 2 and you look around the room, you see young people, old people, and a range of adults as well. Okay, so as far as the variation goes, group 2 has more variation because if we're looking at the definition here, it says, are things quite different from each other, or are they all quite similar to each other? So with group 1, you have, at least with respect to age, you have a bunch of the biggest chunk of people, most of the people in that room are quite similar to each other in that they are all minors, okay, that they're all, you know, they might be little kids or teens or who knows. All we know is that they are between the ages of 0 and 17, so they are all in the minor category where they are similar to each other in that, and you only have 3 or 4 people who don't fit into that category, okay? Whereas in group 2, you have a mix of minors, adults, and seniors, and so that would count as having more variation. Okay, if you know, looking at the bar chart, it seems like, oh, these are all the same height, so that's not a sign of variation, but that's actually a sign of variation when it's coming to a categorical variable. If the bars are all of similar height, then that means each of the different categories are, nearly equally represented or well represented, and that you've got a variety or variation in the categories. Whereas in group 1, where one bar is very dominant compared to the other bars, you don't have much variation there. Okay, does that distinction make sense there? Okay, as far as variation goes with categorical data. Okay, so these are ways to display categorical data. There is another way to display categorical data, but this is not preferred. Okay, so another way to display categorical data is with the pie chart. Okay, but this is not a preferred method. Okay, so pie chart looks something like this. Okay. Okay, and then, maybe we feel fancy and we feel like coloring these in or something like that. I mean, they look nice. Whoops. But, where's my... All right, well, okay, I won't color these in. But, all right, so, let me just label these. So we got A, B, C, D, and E, okay? Now, the reason why I don't like pie charts is because I could ask, which one's the biggest, and you can say E is the largest. But if I asked you which is bigger, A or C or B, it's a little bit harder, right? A versus B versus C, this is much tougher to distinguish. Okay? Okay. Whereas with a bar chart, our eyes are very well trained to compare similar but different height bars. Okay, so if we call this, if this is A, B, and C, it's very easy to see that B is greater than A, which is greater than C. Okay, we can rank the bars. It's much more easier to rank the heights of the bars. Okay. And so this is what we have for displaying categorical data, okay? And I think for our first lecture, we'll just end a little bit early today, and we'll see you guys next week. There is a quiz next week, so make sure you do the homework that's posted online, and study for the quiz. The quiz will get started at 7 o'clock, so please be sure you arrive here on time. Okay, have a good night, you guys.